Hi, this is Dave Perellis again. In this XYZs of Oscilloscopes video, I'm going to show you how to use automated measurements in a digital oscilloscope. In this video, I'm going to focus on basic time and amplitude measurements. I'm going to use this TBS2000 oscilloscope and a function generator, but many of the techniques I'm going to show you can be used on other scopes as well. In the previous video, we measured time and amplitude characteristics using oscilloscope graticule and cursors. These visual measurement techniques provide great estimates of voltage and time. However, their accuracy is limited by graticule resolution, cursor alignment, and display resolution. Modern digital oscilloscopes provide built-in automated measurement functions that perform measurements on the digital signal data converted by the analog to digital converter in the scope. Since the measurements are performed on digitized signal values, they aren't subject to errors introduced by eye. Let's have a look at the setup. On this oscilloscope, the measurement function is activated by pressing the Measure button. The measurement menu provides a categorized list of all the measurement functions available. I can scroll through the measurements and select the ones I want. On this scope, tips show up at the bottom to explain the differences between each measurement. Since I'm focusing on basic measurements here, I'm going to choose frequency, period, peak to peak, max, and min. The measurements show up on the display alongside the waveform, and you didn't have to do any multiplication or subtraction. Changing the vertical scale to make the most of the range of the scope will improve the accuracy of your measurements. However, the waveform should stay inside the scope display. If the waveform is clipped, the measurements will be unreliable and you'll get a warning. Similarly, if the horizontal scale is too low and the instrument doesn't have more than a complete cycle, it won't be able to compute period or frequency measurements. Some measurements involve more than one channel, phase or delay measurements, for example. For these measurements, you have to specify which channel to use. The first channel you specify is usually the reference. Let's add a phase measurement from channel 1 to channel 2. Let's also turn on frequency and peak-to-peak measurements for the signal on channel 2. Notice that the phase measurement gives a negative reading, which means that channel 1 is leading channel 2. The measurements for channel 2 are shown in light blue, the same color as the waveform. On this scope, the automated measurement functions give you the option to define the portion of the waveform used to calculate the measurement. This is called measurement gating. The default option is the entire waveform, or full record length. This means any measurement you select would be applied to the entire waveform data. The other options are screen gating, which applies the measurement to the portion of the waveform that's on the display, and cursor gating, which measures the waveform between time cursors. So now you know how to use automated measurements to perform basic time and amplitude measurements on an oscilloscope. In the next video tutorial in the XYZ series, we'll show you how to use more automated measurements to further characterize analog signals and power waveforms. Thanks for watching.
Find out more at Vicom's website.